All right, we are in section 6.6 where we're going to look at uh, scale drawings and scale factor. So if we look at the beginning of our slide, we have two definitions. One, we have a scale drawing, and the other one, we have a scale model. So when we're talking about scale drawings, we're talking about a two-dimensional drawing that is similar to the object that's representing, such as like blueprints for a house, um, you know, large buildings such as schools, hospitals, stuff like that. Uh, Scale model is three-dimensional. Uh, I don't know. The biggest example that I can think of is when uh, when you purchase like uh, like model cars, model planes, stuff like that. They actually have a scale to it where it's like 1 to something, which means that it's that, or like say like it's 1 to 20 or something, kind of like that. Saying that means like for whatever size it is in the model, it's 20 times larger in the real life version. So that's what that's when you see those scale factors, whether we talk about scale drawings or the the ratio of it all. So the scale, it says, it's just the ratio of a drawing or model's dimensions to the actual object. So like they say here, it says 1 centimeter to 50 meters. So in the scale version, 1 centimeter represents 50 meters. So that must be talking about like a map. And if you looked at the map and you took like a measure, a ruler, in this case would be centimeters, you measured it to 1 centimeter, that represents 50 meters in that particular map. So, let's say here we have, a map of Wisconsin. And if you look here, this is uh, the to help you determine what the scale factor is in a particular um, map dimensions. So what you can do is this, and it'll look different for you guys because, I don't know how close this measurement is. So if you were to take this ruler and measure it onto here, it looks like I have 2 inches equals uh, 90 miles. So you could say, right here, I'm just gonna make a note, 2 inches, it will equal 90 miles. So if I were to plug this in here, and put this on any portion of the map, you could say like, oh, I got lacrosse right there, and I don't know if I can, looks like lacrosse to Fond du Lac looks like it's like three, let's just say it's almost 3.5 inches in measurement. So what we can do is we could use that scale, write it as a proportion to help us figure out, how far lacrosse is to Fond du Lac, as the crow flies, not taking into account anything with, roads, highways, stuff like that. It's not like it's Google Maps and it's telling you like, oh, it's this distance. That's the distance it would be in driving time. So what you could say here is, all right, I got 90 miles over 2 inches, because those are proportional, would be equal to, I don't know the mileage it is from, say, lacrosse to Fond du Lac, but I said I got a measurement of 3.5 inches. And so you could do the cross products here to figure out the value, and get pretty close. So 3.5 times 90 is what, 315, and that equals 2x, dividing everything by 2. So x would equal 157.5 miles. So across the font of x about 157.5 miles. All right, give or take. So that's how you can determine uh, what the actual size is or what the scale size should be for not just a map, but for any kind of drawings or scale models, stuff like that. So, so what sometimes you are given the scale factor. So, like in this situation, they're telling you in these particular examples, this is separate from the map up above. It's telling you that 1 centimeter to 500 meters. So you are going to use the given map distance to find the actual distance. So both examples A and examples B are map distances. And so you're going to be asked to find what the actual distance is. All right. So what we get to do here is, all right, so we write in 1 centimeter over 500 meters will be proportional to, in this case, it'll be 6 centimeters. Make sure you keep the centimeters on top over x meters. So when you do the cross products, 1 times x is x. 500 times it by 6 is 3,000. So I got 3,000 and it would be meters. So 3,000 meters would be the result of measuring something that was 6 centimeters with this scale factor. Same thing goes here. We got 9.1 centimeters. So I just write, oops, let's write the scale factor first. So I go 1 centimeter over 500 meters. That's going to be equal to 9.1 centimeters over x meters. Again, 1 times x is still going to be x. 500 times by 9.1 gives me 4,550 meters. Okay. Looking at the example below, they give us now a different scale factor. So it says 1 inch is to 15 miles. It says use the actual distance to find the distance on the map. So these are actual distances. Uh, so I go here, I write in my scale factor, which was 1 inch over 15 miles. To write this in, I don't know what the distance on the map is, so I'm going to write that as x, and it's going to be over 112 miles. So if you realize here, I got inches on the top, I got miles on the bottom. I'm keeping it consistent. When I do the cross products, I get 15x is going to be equal to 1 times 12.5. 112.5 is 112.5. And then to figure out what it's going to be, I take 112.5 divided by 15, which means x will equal 7.5, and it would be inches. All right, same idea goes when it's 45 miles. You write in the scale factor, 1 inch over 15 miles is going to be equal to, we don't know what x is or what the inches is, so we write it in as a variable x, but we do know that it's going to want to represent 45 miles. So again, do the cross products. I get 1 times 45, which is 45. 15 times x is 15x. Dividing both sides by 15, I get x equals 3, and it would be 3 inches. All right, again, you have a scale factor. And in this case, the scale factor is 1 centimeter to 8 kilometers. So what you got to be careful with is all you got to do is read the passage carefully, make sure you place them in the correct spots in the proportion, and then solve it using cross products. So again, writing this out, 1 centimeter over 8 kilometers, it's going to be equal to. So if I read this, it says, what is the map distance of a road 48 kilometers long? So they give us the 48 kilometers. What they want us to find is what it's going to be written in centimeters. We don't know what that is, so we'll represent it as x. Do the cross products. 1 times 48 is 48. 8 times x is 8x. Divide everything by 8. X will equal 6 centimeters. So looking at the next passage here, the next sentence says, what is the actual distance of a road on a map that is 12 centimeters long? So again, we write out our scale factor to begin with, and we have 12 centimeters. So they give us the centimeters. What they're looking for is the actual distance in kilometers. So write this in. 1 times x is x. 8 times 12 is 96, and it would be 96 kilometers. One of the other things that we're going to try to look at is going to try to write a scale factor. Sometimes you are given the actual distance that something is, whether it's a part, whether it's a map, whatever it could be, you'll get the actual distance and you'll get the scale distance. So when it comes to looking at scale, usually it happens when you have no units involved. So, and the only way to get rid of the units is they must be the same. They have to be the same units. So that means if you look here, I have 1 centimeter to 15 meters. So if I wrote this as a fraction, I'd be 1 centimeter. Oops, not 15, it would be 5 meters. 1 centimeter to 5 meters, my apologies. So 1 centimeter to 5 meters. So what you have to do now is you must determine what is the largest measurement. Is 1 meter or 1 centimeter larger? All right. 1 meter is larger than 1 centimeter. So that means that meter is the largest unit. So what we're going to do is, since that is our largest unit, I'm going to try to get rid of the meters value. So that means we have to do some dimensional analysis, what we did before. We got to multiply by another fraction. If meters is on the bottom, I'm going to put meters on the top, and I can put centimeters on the bottom. So what that means is we can have a scale factor. We know that 1 meter is how many centimeters? We know that 1 meter is equivalent to 100 centimeters. I got meters on the top, I got meters on the bottom. Those now cancel. So now it equals all the way across 1 centimeter to 500 centimeters. And again, we got centimeters on the top and centimeters on the bottom. Those also cancel. So that means now I have my scale with no units, which is 1 over 500. Looking at another example, I have 1 inch to 3 yards. So again, I go 1 inch over 3 yards. So again, I got to ask myself, is 1 inch larger than 1 yard? The answer is no. 1 yard is larger than 1 inch. So that means that's uh, where we look at when it comes to finding out scale factor. So I get yards on the bottom. Uh, at the moment, let's use feet as my next uh, value. So I know that 3 feet equal 1 yard. So this gets canceled and this gets canceled. So now they're still not the same yet. So now I go over here, make another one, and I can put feet on the top and inches on the bottom, I know 1 foot equals 12 inches. Feet and feet get canceled. So now multiply it across. 1 times 1 times 1 is 1, and left with inches. And then 3 times 12 is 108 inches. And then finally, inches and inches cancel. So now I'm left with 101 over 108. And then to finish up, these are just some uh, unit conversions that may help you throughout the course of being able to solve these problems to determine different scale factors and whatnot. 10 millimeters is the same as 1 centimeter, 100 centimeters is the same as 1 meter, 1,000 meters is the same as 1 kilogram, 12 inches is the same as 1 foot, 3 feet is the same as 1 yard. You know, we can add some more to this. We can say that, you know, 5,280 feet is the same as 1 mile. Um, so yeah, and we can add some uh, periodically, and you can look things up too as we go along. And that is looking at scale drawings. Hope this helps. Until next time.